Okay, so in this video, I'm going to be continuing the series on dot products. So I'm going to start by saying if I have some vector A over here, we can give it the coordinates 2, 3. I'll just pretend that's 2 and that's 3, might be off a little bit. That this vector has some sort of magnitude, some sort of length to it, and also some sort of angle to it. And it doesn't matter where I put this. For example, this, as long as that theta is the same and that length, that magnitude, that force is the same, I still have that same vector. And so one of the things that we can do is we could, to see what the coordinates, if it's centered at the origin is we can put it back to the center. But first, before we do that, I'm going to try and find the length of this. So it's basically just Pythagorean's theorem. I have this length over 2 here and this length, which is a 3 over here. So this magnitude over here, this length or this force, would be the root of the sum of the two square, the sum of the square of the two lengths, which equals root 4 plus 9, which is root 13. And so this over here, we would say its magnitude is equal to root 13. All right, so now I saw now if it's out of center, how we can recenter it. So if I say that I have on my handy dandy plane over here, I have 1 point here and 1 point here. And that right there makes a vector. We'll say it has coordinates 2, minus 5. I'll call this point B, this point C. We'll say that this has the point 5, 3. Now, and this right here is vector A. I'm going to find out what vector A is if I put it back at the origin. So vector A is equal to the vector from B to C. And that's equal to, well, if I take this and I subtract it from that, then I should be able to recenter it. So I would say it's equal to 5 minus 2, comma, 3 minus negative 5, which equals 3, comma, 8. And so now we can go on to doing some addition with multiple vectors. So if I have a vector u and a vector w over here, then this right here, this vector over here, is just the u vector plus the w vector. Nothing too special to it. And so if I say, just like I was saying before, that I can move around all of the vectors and they're still the same vector because they still have the same magnitude and the same angle, or the same direction. If I move this w over here and I ask you, what is u plus, I guess it's at the other, plus w, then this right over here would still be the same thing. This length over here, because it's just this over here, would still be u plus w, because all you have to do to show that is to move that vector over there, and then that line is the sum of that and that. And so we can go on and we could do some subtraction with it. So if I ask you, if I say this, I have this v vector over here and this u vector going out over here. What is this over here? We'll start by calling it a box. There are two ways to do it. One way that you could do it is you could say that you could move this around and you could just call it a negative. For example, this vector over here would be negative v. And then you know that this vector over here, which is the same thing as this vector here, is the summation of those two as we proved over here. So it would be u minus v. But another way that you could do it is you could say that v plus that box will give you that u vector. And then you could solve for that. So for all of these things, there are most certainly you could do it this first way, and sometimes you could also do it the second way. And we'll see that we come out to the same answer. So we get that that is equal to u vector minus v vector. And now we can move on just a little bit. If I say, where's my eraser? I don't even need it. If I say that I have a vector, or the initial point, a, which equals 0, 1, 4. So that means that on my 3D graph, we start at 0 on the x, 1 on the y, and 4 up. So it would be right over here. And then the final point, which is called, I'll just call it the final point, or the terminal point, that's what it's called. The term point will be b, which is, oh, these are coordinates, not vectors, excuse me, which has, I'll say, 2, 4, 8. Then the vector AB would have to be, I'd say, 2, then 4 out, and then 8 up. It'd be like over here. Then the vector AB would be all of the B components minus all of the A corresponding components. So I do 2 minus 0, and then 4 minus 1, and then 8 minus 4. And I get this nice vector AB, which is 2, 3, 4. Okay, and now there's one more thing I want to do in this video. If I say that A equals the vector 4, 0, negative 3, and B vector equals 3, 4, 2, then if I say find A plus 2B, I would have to first multiply by B by 2 and then add up all of the corresponding points. So I'm going to do that right now. So again, it's going to be a new vector. So I would say 4 plus 2 times 3, comma, 0 plus 2 times 4, comma, negative 3 plus 2 times 2. And that equals 6, 10, 8, 1. And that right there would be our answer. And if it also said find the magnitude of A, I would just do the Pythagorean theorem but apply it to 3 variables. So I would say 4 squared plus 0 squared plus negative 3 squared, which equals the root of 16 plus 9, which equals the root of 25, which equals 5. So it has a length of 5. That will do it for today's video. Thank you very much for watching, and goodbye.